What's up, guys? My name is Michael Lin. Welcome to my YouTube channel. Today we are going to do a virtual contest, Codeforces round 658. I have not looked at any of these problems before, but yeah. In the morning, I was going to do @Coder ACL contest, but then I couldn't wake up early. Like, I woke up early and I was like, okay, I got to do it. And I was like, yeah, I'm too tired because it's at 8 o'clock for me, and it's just 8 a.m. so early in the morning. I mean, I'm really lazy as a person. I don't know. Let me know in the comment section down below if you guys have trouble waking up early, because I'm trying to wake up early. I need to fix my sleep schedule. COVID has completely knocked my sleep schedule down. But yeah, we are going to start this Codeforces round 658. Let's see if I could solve at least one problem. If I can't, then, well, I tried. And yeah, I'm gonna go over a solution of the recent Codeforces contests later. I'm going to create like 2 videos of them, basically just explaining how to do it. Yeah. And yeah, that'll be later, and I'll also create some videos of I gotta create some videos of some algorithm videos, because I have not done those either yet. So yeah, right now it's like I have a bunch of stuff I gotta do, but yeah. Let me know, what do you guys think? You know, am I hacking? Are you hacking? What does that mean? Well, who's Nightbot? Are you hacking? No. Who's the Nightbot? This Nightbot's so cool. Am I ready? Yes, I am ready. Are you ready? Cydrus, are you ready? I want to know how like the other people, how people in like there's like a way to like re-edit your live stream so that it actually shows the people who comment, and like I don't know how to do that actually. Is it like, I have no idea. I don't know how to do that. So like, is then I could choose whoever's the one that's commenting, and then it like pops up. I don't know how I think Coding Phase does that, and also Derek Banaz does that. I don't know how to do it though. I gotta learn how to use these YouTube live streaming, you know. But yeah, there's a delay. Whoops, I don't know why. I have no clue why there's a delay. Is it gone? Is the delay gone? Whoops. Is the delay gone, guys? Can I do a DOS attack on Netflix? I don't know. Who is this guy? Who is this guy? Who is this guy? Anyway, okay, we're starting now. Who is? Okay, common subsequence. There's a delay. You're given two array integers. Okay. You need to find a non-empty array that is a subsequence of that, and also subsequence of that. If there are multiple answers, find one smallest possible length. If there are still multiple of the smallest possible length, find any. If no such array, report it. Okay. A subsequence, if it could be attained by deleting several possible 0 elements. So 3-1 is a subsequence of 3-2-1 and 4-3-1. But not a subsequence of 1-3-3-7 and 3-10-4. Find one of the smallest possible length. Can I just pick one? Can I just pick one element from one array and one from the other? Can I do that? Let's see. Okay, we have N and M. A1. Okay, so 10, 8, 6, 4, 1, 2, 3, 4, 5. It's guaranteed that the sum is between. Okay. Well, what is it? What is the answer? The answer is yes. One and 4. In first case, 4 is a subsequence of that, and the array has a array length 1. Okay, yeah. Okay, so can't we just pick one element from? We could just pick one element from both the array and then just print that out. If we can't, then we just print out, if we can't, just print out -1. Okay. So yeah, so let's do like t, cnt, while t minus minus. What do we have to do? nm a1a. Okay, so we're gonna read in n m, and we're gonna just read in the array. So here we're gonna have array a, and then we're gonna read in a at I. Okay, this one let's use n and m. And then we're gonna read in creative array B, and then we're gonna read in B. Okay, and then what we're gonna do is we're just gonna check loop through array A and B. Let's see. We could actually use a set. Yeah, so add all the elements of A into it, into the set, and then for B, we'll add all elements of B. When we go through B, we just check if there exists an element in A, in the set that's an element of B, right? So then if there does exist, we just break. If there does exist, then we say it's yes, and then we insert it. We have that one element, so let's create like a 1L. Okay, we set a -1. For now, let's do a set. This is gonna be same, and here we're gonna insert same dot insert at a of I. Right. So then here when we're at B, we're gonna check, does there exist? Find same dot begin, same dot end. We need to find B of I, and if it's not equal to same dot end, I think this is right. Is this how it works? I forgot the function. Oh, yeah, it's like this. Okay, so if it's not equal to the end, that means it's inside the that means we found it. Like if we're finding in the set, right? If it's not equal to the end, that means we found it. So we're going to say one element is equal to B of I. Yeah. One element is equal to B of I. Yep. And then in the end, let's check if one element is not equal to -1. We'll just print out yes. And then we just print out 1 and then the one element. Okay. Otherwise we print out no. Okay. Let's just save this and submit this. Because they wanted the smallest length possible, so it's always going to be 1. Runtime error. What is my runtime error? Exit code -1000. What's my runtime error? Hold up. I did not run this yet, so. Out of range. Vector out of range. Oh, here. It should be M. Have length M. I think this would work. What's the problem? What's the problem? Oh. A's range. I'm doing something right now. Wait. 141133. Yes, 1311. So 14. Yes, 13. 4 3 4 5 5 1000. Yes, 13. So there should be one no. Yeah, there's one now. Okay. I think this would work. Stop. No. Yeah, I got a seed. Okay. That's fine, and let's do the next problem. Let's see. Do I know Elliot Anderson? Alderson. From Mr. Robot? Should I go over some cybersecurity videos? If you guys want. Are you an actual Nightbot? I don't know if this person's an actual Nightbot or not. That's strange. I don't know. I'm not sure. What do you guys yeah, DDoS attack on Netflix? I don't think so. There are N piles of stones. There's the ith pile has the A of I stone. 2 players play a game where they take alternative stones, removing stones, and 1 player you can remove a positive number of stones from the first pile. Pile with the minimum index that has at least 1 stone. The first player cannot make a move and loses the game. Both players play optimally, whether they're winner of the game. What does he mean? You have A of I stones. 2 players play a game. They could alternating restart turns, removing stones. And 1 move, a player may remove a positive number of stones from the first non-empty pile. The player who cannot make a move loses the game. I don't understand. Oh, let's read in the input first. So first is T, then N, and then A of N. T, N, then A of N. T, N, A of N. So if we do like T, N, A of N. Okay. So let's say we have 1, 3, 2, 5, 4 in the first place. The first player could take the stones from the first pile, so then we would have 5, 4, right? We take 1 stone. Oh, okay, so we have 1, 5, 4. Second player should take the stones from the first pile, so we would have 0, 5, 4. Okay. First player should take the stones from the first pile because it's the first pile's the second pile because the first pile is empty, so we take 4 stones. Wait. You would take 4 stones? What? Second player could take the stones from the second pile because the first pile is empty. You would take 1 stone, but you can't take any other stones, so it would be 0, 0, 4. First player should take the stones from the second, third pile because the first pile, so you would take 4 stones, so you would get 0, 0. Second player loses the game. So they could alternating turns removing stones. In 1 move, you remove a positive number of stones from the first pile. The minimum index. First player who cannot make a move loses the game. Both players play optimally. Do you just remove the... One player removes N minus 1 from the... So first player would remove N minus 1, right? So, or AI 1 minus 1. So if we have 2, 5, 4, the first player is going to remove 1 from 2 because 2 is the largest. 2 minus 1 is 1, right? So we're going to remove all the values except for 1 stone, okay? Then the second player removes that 1 stone, and you can't take any number of stones. Third player removes the 3rd stone. The second player removes the 5th stone. You would take 4 stones. Yeah, okay. So the first player would move N minus 1 again stones. And then you get a 0, 1, 4, and then maybe I don't care.
You don't care?
I don't care.
Okay, hot dog or Big Mac?
Uh,
Hot dog or Big Mac?
maybe hot dogs. I don't know.
Okay. Good one.
Okay, N -1 stones. The first player takes the stone from the second pile because the first pile is empty. Numbers the stones in a 0, 1, 4. The second player should take the stones from the first pile because the first pile is empty. He would take 1 stone because he can't take any number of stones. So what if for each element you remove a of 1, a of I -1? Right. So for each one you remove all the values of the one, and then the second person would just keep taking 1 stone. No, but in the last case he takes all 4 stones. Let's see. So when you get to the last one, so the first player would keep taking N -1 stones. If it's 1, we just take all 1, right? But until we reach the last pile, and then he will take all the stones, and then the second player would just lose. So yeah, that's how my thinking would work. I'm not sure if this would work though. I don't know how you would prove this solution. What do you guys think? Yes. Kali Linux. No, I don't have Kali Linux. I've used Linux before, but I do have Linux. I have Ubuntu. I mean, if you want to do Kali Linux, I don't know. It's kind of crazy. Yeah, it's gone. I don't know. Okay. Okay. So yeah, that's what we're gonna do here. Let's just. Yeah. So we need two players. So we need a first turn. So if it's the first turn, first we're gonna set first turn is true, right? So this first is gonna represent whose turn it is. Yeah. So we're gonna loop through all the values in our array, which is yeah, we're gonna loop through all the values. If it's the first turn, then we are going to remove N -1 element from the array. So A of I, we're gonna subtract all the values except for 1. So technically we're just making it 1, honestly. Yeah, that's basically what we're doing. If it's not the first turn, we're going to make A of I to 0. If we are at the end, we make A of I back to 0, right? Yeah, if we're at the end, so here I need another if statement. So this one, if I is equal to N -1, so we're at the end, right? If we're at the end, we are going to make the value to be 0. And then the first one, we're going to make it to 1. Yeah, otherwise we make it to 1. So at the end, we're going to make the value 0. If we are at the end, so okay, so now here's the problem. If we're at the end and the value is 0 already. That means one of the players lost, right? So, let's see. Let's think if we're at the end and one of the players has lost, then we would have to do. Yeah, if we're at the end and one of the players lost, then we would have to set it to 0. Yeah. Let's see. Let's think. Yeah. Okay. Let's keep trying. Okay. So if we're at the end, let's say we're at the end, right? Yeah. Let's just say we're at the end, and so that means. So here that means if I is equal to n minus 1, so we're at the end, and if ai is already equal to 0, so this is else this we set it equals 0. If it's already equal to 0, then that means player 1 lost. Yeah. So if it's the first player, then that means player 1 lost. So player 1 lost is false. So here we're gonna we're gonna have a boolean that says player 1 lost is false. Here we means player 1 lost is equal to true. Yeah, so that means player 1 lost. Now let's see if we're at the second turn. Now if it's the second player's turn, we need to so normally you just set it to 0, but if a of I is already 0, then that means the second player lost. So second player lost. So that means player 1 lost equals to true. Yeah. So if a of I is already 0, that means that second player lost. So that means player 1 lost is going to equal to false, right? So that means player 1 lost is equal to false, and otherwise we just set equal to 0. Okay. In the end, here we have to reset. We have to change player 1 to player 2. So player 1 is player. Wait, what was the boolean I put? Oh, first. Yeah, so first player is going to equal to not first. So this would make it. So first player, originally it's first player's turn. Now it's second player's turn. When it's second player's turn, it's going to go to first player's turn. So that's what this does. Okay. After this, what do we have to do? Yeah, if player 1 lost, put true, otherwise put false. Okay, so if player 1 lost, we're going to print out second and then yeah, otherwise print out first. Okay. Okay, I'm going to now, let's just submit it and see what happens. I mean, what could possibly go wrong? You know, this is a virtual contest. It doesn't even matter. Let's see. Wrong answer on 1. What's the problem? First. Okay. Why is it all first? Player 1 loss is true. I don't know. Let me check the status. Go to sleep, kid. It's late in your country. Side dress, I think your So these are virtual contests, so they don't actually count. That's what I like about it. So if you want to do a virtual contest, it doesn't really matter. Like, even if you can't solve it, it's like, it is what it is. Like, most of it is just preparing for you for interviews. But yeah, or preparing you to try to solve problems. Yeah, okay. So let's just go back to this case. Let's see, what are we doing wrong? So 254, let's just try 254. So if it's 254, so let's do 1 3, there's a 3, 1 3 2 5 4. Okay, so originally it's first. That's not true. Then we're gonna set first to 1. So originally it's 2, and then we're gonna set it to 1. Yeah. Now it's gonna be second is equal to 0. It's not. So we're gonna, oh, whoops. Oh. My fault. We went to the next index without actually moving it. So you don't want to increment the next index until a of I is 0, right? So here in this case, we have to change this into a while loop. Okay, so we're gonna make this into a while loop. So okay, so now we have to increment the next index when the value is, when you set it to 0. So in any case, when it's set to 0, we increment to the next index. So this one we do I++ here, I++ here. Yeah. Okay. Now let's do this. Let's try it again. So we have 1 3 2 5 4. Okay, so first one is false. So then we're gonna set the. So it's first it's the first player's turn. Now we're gonna make it first. Take everything besides 1. And it's gonna be second player's turn. We're gonna make it 0. So now we increment where we go next. Now it's going to be first player's turn again. We're not at the end, so we're gonna set this to 1. Then we set it to false. Now it's second player's turn. If it's second player's turn, we set this one to 0. Increment that. Now we are at this place, and then we're just going to set this to 0. Increment that. Okay, so now at the end, if it's the first player, well, I didn't have an end condition at the end. Okay, so now here, we have to check if it's the first whose turn it is. So, yeah. In that case, we don't actually have to check we don't have to do these checks. We just have to do these checks at the end. So we don't actually need to do this. Yeah, okay. My bad, guys. So we could just move these checks to the end. So I could just move this to the end. So yeah. And then I just change this. So then it gets into that. So yeah, okay. So at the end, I is going to be n. So we actually have to check the last value. So if the last value is 0 and it's the first player's turn, then that means first lost, right? So that means we print out second. Otherwise, we print out first. Okay, And we don't need the Boolean of player 1 lost, player 2 lost. So we don't need this. Because we just have to check out at the end. Right? Yeah. Okay. Let's just see. What does this give us? So we have 1, 3, 2, 5, 4. So you set 0 to 1. So 1, 0, 1, 0. Okay. Now it's the whose player's turn. It's second one, so he lost, so it's first. Okay. Yeah. So I think that's right. So now let's just see if this is working. Let's not create a breakpoint. First. Okay, why does it keep doing first? First, second, first. That's a tough question. Why does it keep doing first? By the way, what time zone are you guys in? I can't even open this for some reason. Why can't I open this? Whatever. Whatever. Oh, okay. I can open it now. But yeah, guys, we're just having a discussion here. Let's just hang out here, all right? What are you guys up to? What time is it in where you guys are at? Come on. We're just having an open discussion here. So, Mr. Robot. So I have watched Mr. Robot before. I have not watched season 3. But yeah. Kali Linux. If you wanted to go over like cybersecurity stuff, we could do that. Could do that, okay? It's late in your country. Are you an actual Nightbot? Are you an actual Nightbot though? Yeah. Is it very late? It's kind of... Is it late for you guys? I don't know. Nightbot. What is it like to be... See, I don't know. I haven't actually watched season... I haven't actually watched season 3 of yeah. I don't know what a Nightbot is. What is a Nightbot? I've actually never seen this person in any of... Oh, it's a chatbot that allows you to automate your live streams chat with moderators. Huh. Maybe I should get a Nightbot. I don't know. Nightbot. That's so cool. That is actually pretty cool. But like that's the thing, it's like I don't want like a bot just to like delete every single you know what I mean? Like every single comment in live chat. Because that wouldn't be fair. You know, it's freedom of speech. You know what I mean? Freedom of speech. Yeah, but why is there a Nightbot in their live stream now? I never actually had a Nightbot. Like, I never thought of doing a Nightbot actually. I don't know, dude. I don't know. Back to this problem. Why is it always outputting first? So if we have 1, -1, 0. This shouldn't be equal to 1. This should equal to minus equal of a of I minus 1. So if we're at 1. Crap. Okay. If it's first turn and we're at 1, just 1, we just subtract 1. Right? So if let's just make it 0. Yeah. So if a of I is equal to 1, we're going to make it to 0. Yeah. Here we're going to put else if. Make it to 0 and then I plus plus. We actually can make this an or. Clean up the code a little better. So yeah. Or a of I equals 1. So yeah, so if it's 1, we just set to 0, make it I plus plus. Otherwise, we just make it equal to 1. I think this would make it equal to 1. Yeah. This should make it equal to 1. Yeah, let's see if this works now. Why? First, second, first, second, first. First, second. Oh, this one's wrong. First, second, first, second, first. So 1, 2, 3, 4, 5, 6 is wrong. Why is 1, 2, 3, 4, 5, 6 wrong? Okay. Let's debug this. 1, 6, 1, 2, 3, 4, 5, 6. Okay, so we start at the first one. It's 1, so we are going to set it to 0. Move up to I. Now it's going to be 2. 2's turn. We are actually going to set it equal to 0. Is that right? Did they set it to 0? You'll take 1 stone but can't take any number of stones. Maybe we should do the same thing for second player. Yeah, let's do the same thing for second player. So if we're at the end, we're just going to set it to 0. Otherwise, if it's equal to 1, we set it to 0. Yeah. Yeah. We're going to do the same thing for second player. So we copy this, do the exact same thing here. So second player is going to take n minus 1 also. Yeah, okay. Let's see if this changes anything. So let's see. That's not what I wanted to do. First, second, first, first. First, second, first, second, first. Now we're getting the second one wrong. Second, first. Second, first. First, second to second, first. We're getting this wrong. First, second, first. First, second, first, second, first. First, second, first, second, first. Okay, we're getting 2 wrongs. Okay. 1, 1, 2, 1, 2, 2. 1, 1, 2, 1, 2, 2. He takes 1 stone from the pile. Second player should take 1 stone from the pile. Under 4 and 5, 4. The first player should take the stones from the second pile because it's empty, so we would take 4 stones now. And we're stone. Second player should take the stones from the first, second pile. Number of stones in the pile would be 0, 0, 4. Yeah. If he So here they're taking 1. I don't know actually. I don't know. I don't know. Let's look at this case 1 2 2 1 1. 1 5 1 2 2 1 1. Why is it first? That's a big question. Why is it first? 1 2 2 1 1. So first one, 1 2 2 1 1. So first one we set it to 0. Now we're at the second one. He's going to set. He's not going to take all of it, is he? It takes just one. First one we're going to set to 0. Second one he's going to take just 1. First one he's going to take just 1. Second one he's going to take 1. First one he's only going to take that. Now it's second's turn. Second can't take anything, so it's first one's. We have to think of a scenario why first would win here. Why second would win here. Let's say first takes 1. Then you have 2 2 1 1. Second takes all of it. So let's say second takes all of it. So then you would take 0. First would take all but 1. So you would have 1. Second takes all of it. So it becomes 0. First takes all of it. Oh, yeah. Takes all of it. Yeah, 1. Second takes all of it. It's first turn. He loses. So does that mean... First player cannot remove a game. Let me think. All right, in 19 minutes, if we still can't solve it, we're looking at the editorial. Because I don't know why... I don't know. Not sure. What do you guys think? Let me know in the comment section down below. I feel like it's one of those things where it's like, I don't know. So the problem with these problems is that if you don't get it, then it's like, oh crap, I don't get it. And then once you do see the answer, like they explain the answer, you're like, yeah, I should have thought about that. But then when an actual contest comes, you might not actually get it, because these are like observation problems. So yeah, I don't know. Actually don't know. One of them sets all to 0, I guess. Here I set to 0. But that doesn't do the 1, 2, 3, 4, 5, 6 right. Maybe it's a number of ones. 3, 1, 2, 3. 3 mod by 2. 1 second, no. Number of continuous ones? 1, 2, 3, 4, 5. 2. 2 mod by 2 would give you 0, so that would give you first. 2 mod by 0. 2 would give you 0. That would give you... No, that's not right. Oh no. Oh no, yeah. Oh. I don't know. These are hard. I don't know how they want. I don't know how you're gonna see if they're choosing it optimally. Okay, so like if you have 2 to 4, you want them to win. You want to win, so what do? Do you take all 4 or do you take only 3? That's the big question we have here. When do you get to choose? When do you take all of 4? Like, I thought you would take all of 4 when you're at the end. But let's say you are... Okay, so let's say we have like 2 and 1. I don't feel like getting out my pen, but let's say we have 2, 1. Or 4, 1. Right? If I'm the first player, do I take all of 4? Or do I take only 1? Oh, do I take only 3? So that gets me 1, 1. Let's say I take all of 4. Right? Then the first value would be 0. So the first value becomes 0. And then the second one's 1. Second player would have no choice but to take 1. I lose. Okay. But if I were to take all of only 3, so if I take 3, first player would choose. So if I take all 3 stones from the first one, right, it would get me 1, 1. Second player would have to only take the first one, so it would get me 0, 1. And then first player would take the last one, so it would get me 0, 0. And then second player loses. He can't take anything. So what is the optimal way to do it? For the first player, you should take all of n minus 1. For the second player, you should take... Let's say it's the second player's turn. Okay, so the second player's turn is 0, 4, 1. Okay, so if the second player takes 0... No, okay, so now it's my second player's turn. If the second player takes all of 4, then it gets 0, 1. First player would have no choice but take 1. 0, 0, 0. Second player loses. If it's a second player, and I take 4, I take only 3. So I get 1, 1. Then if I only take 3, Second player, I only take 3. So then the first player has no choice but to take 1. So then that I get me 0, 0, 1. Second player has no choice but to take 1. First player loses. So if we want to wow, okay, so if it's greater than if it's greater than the next value, you only subtract n minus 1. If it's less than the next value, okay, so if it's greater, we do n minus 1. What if we have a case where it's less than? So what do we have? 1, 2, 3. Okay. First player takes 0. Second player takes, let's say second player takes n minus 1. So we have 1. First player has no choice but to take the 1. So we have 0, 0. Second player instead takes n minus 1. So we would do 0, 0, 1. First player has no choice. Take 1. Second player wins. Second player wins. So this is for assuming first player wins. But then what if you take all? Okay. First player takes all. 0, 0, 2, 3. Second takes all. 0, 0, 3. First player takes all. Second wins. No, wait. First player takes. Second loses. First player wins. First player wins. So if it's less than the next one, take all. Otherwise, take n minus 1. I think that would work. I don't know. Whoa. Maybe we have more chances for the first player to win than to give chance for the second player to win. We have to assume the second player is dumb. I think you kind of depend on editorials because you have solved more than enough to reach green. Yes, you are right. I have dependent on editorials. Maybe I should be able to reach green. Oh no. If the number of stones is greater than 1, then just ignore that pile. Just let us count the number of piles that have 1 stone. So you're saying if you have 1 stone. So yeah, I was thinking about just counting the number of ones, but then I thought like, I don't know if that would work. So you're assuming that the second player is just dumb. I'm trying to. Okay. So because they said both of them are optimally, so both plays optimally. Can you just count the number of ones? I don't know about that. But like, because if we solve the second player, okay, if the second player. It's hard. If the number of stones is greater than 1, just ignore that pile. Just let us count the number of piles having 1 stone. Because it seems that if the number of piles is greater than 1, then the first would pick only 1 less than the stone in total. That might be true. If the number of stones is greater than 1, just ignore that pile. Just let us count the number of piles having 1 stone. Number of piles that have 1 stone. Number of stones. Number of stones. Maybe. Here I am trying to simulate what first and second would do. Yeah, I don't know. Okay, we'll try that. We'll try that. We'll try that. Because if we do like number of piles that have 1 stone. So if you have let's see. If you have number of stones. So if you have 1, 2, 3, 4, 5, 6, 7, 8. There's 8 stones. 8 1 stones, so second wins. 8 mod by 2. If it's even, second wins. If it's odd, first wins. No, that wouldn't work. This one would be 1. So 1 would be 1. I don't know. No, because second didn't win. Or the number of piles that don't have 1. So 1, 2, 3, 4, 5. So 5. If it's odd, then it would be second wins. No, that doesn't work. If it's even, so if we have 1, 2, 2, 1, 1. If trying to think. First wins. Let's think. You have solved more than enough to reach green. Yeah, that is right. I have solved a lot of problems. I have not actually, but I don't think. So like, look, if most of the problems I solved were 800 and 900, so I've gotten faster at solving these, but I have not solved like 1200 problems. So that's the reason why I'm not. I think that's the reason why I'm not in green. But yeah, it's probably the reason. Yeah, I have solved a lot of problems. Not gonna lie, have solved a lot. It is what it is. 1, 2, 15, 12, and 82. But yeah, thinking like maybe if I start solving more, I 1,000 and 1,100. Maybe I'll probably get to green. Oh no. What do you have? What does it take to get to green? I don't know. What do you guys think? Third case is different. Yes, the third case is different. I'm not sure. Third case is different. I don't know. Do people who solve green, do they solve the first two immediately? So I know these guys solved the first, second. Let's see. So some of these cyanides solve them very fast. There's a blue here. Let's see. I don't know. No clue how to do this. No clue. No clue. Huh. Let's see. Let's keep trying. I don't know. Yeah, let's look at the editorial. I don't know. I don't know. I have no idea. I don't know. Let's see. Industrial nim, sequential nim. Wait, hold up. Codeforces. What was it? 658. Editorial. Let's see what they do. Suppose it's greater than 1. If you remove the entire first pile, is winning. Player 1 will do that. Yes, that's what I was thinking. Otherwise, player 1 can leave exactly 1 stone in the pile, forcing player 2 to remove it. Yes, that's what I was thinking. Then it is forced to remove the first pile. Yes. Whichever player gets the first pile with more than 1 stone wins. Yes. Let K be the maximum number such that A of 1 is equal to 1. If K is even, the first player wins. Otherwise, the second player wins. Huh. Ah. Oh. Oh. Okay. Okay. I get it. Okay. Yeah, so their reasoning is that if you're whoever gets the first pile with the largest greater than 1 would win. So if you count all the ones that have 1s, that's the ones that the first player would lose, right? Where they choose, they're forced to pick the one that is less. So yeah. Yeah. So let's close the editorial and try this implementing it ourselves. So if A of I is equal to 1, then we're going to count. count to k plus plus. If k is equal to k mod by 2 is equal to 0, and that means that A wins. 1, 2, 3. A wins. Yeah. Wait, no. Yeah. 1, 2, 3. 3 mod by 2. 1, 2, 3. Yeah, A wins. So then see out first. Else see out second. So now if k is equal to n, then check if k mod by 2 is odd, and that means first wins. Otherwise, second wins. I think this would, yeah. Okay, let's try this. Wrong answer on 1. What is the problem? First, second, second, first, second, first. Do they mean maximum k, continuous k? First, second, second, first. Okay. They might be maximum continuous k. I gotta open this up again. What was it? This one? Codeforces. This one, sequential num. Sequential num problem. Editorial. So if it's removing first one's winning. Maximum number such that they're all even. Okay, so yeah, they mean by like continuous. Okay, so if they're mean by continuous, then you need like a max k. So then else max k is equal to k max of max k and k. Then we have to set k back to 0. Yeah. I think this would work. Then this would be max k. This is going to be max k. Max k. Yeah. I think this would work now. Nope. Alright, what do we do wrong? First, second, first, second, first. First, second, first, second, first. What are you doing wrong? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 2, 3. First one would be 0. 0 mod by first, second, first, second, first. So the answer is first, second, second, first, second, first. First, second, first, second, first. I'm getting a second one wrong. 1, 2, 3, 4, 5, 6, 7, 8. Max k should be 8. Oh, whoops. And you do a check at the end. Yeah. Yep. What is the problem? First, second, second, first, 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 first. Oh my god. Okay. What are we doing wrong? Max K. Let's see. Okay. Let's see. Let's see. What are we doing? What are you doing wrong? If K is even, the first player would win. If K is even, maximum number such that they're all equal to K. Okay, so which one? What are we doing wrong? First, second, second, first, first, second, second, first, second, second. Let's run the code. First, second, second, first. What is wrong? First, first, second, first. 1, 2, 2, 1, 1. 1, 2, 2, 1, 1. Okay. Let's see. 1, 2, 2, 1, 1. One. So max is 0. 1. Max is 0. 2. So max K is 2. Max K is 2. Why isn't the first player winning? It's the second player's winning. Maximum number such that K is equal to 1. If K is even, the first player would win. But the second player wins. Do they mean by like A1, A2, A3, A4? By like 4? The last number? Well, 1, 2, 3, 4, 5. So the last index, that K is equal to 1? Is that what they're looking for? The last index? So not the contiguous number of indexes. So okay, I guess we don't need this then. So if it equals to 1, we just set K is equal to I plus 1. Wrong answer again. What is the problem? First, second, second, first, 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 second. 1, 2, 3, 4, 5. 5 mod by 2 is not equal to 0. 5 is not even. That doesn't make any sense. K is 5. Oh. Oh. K is not equal to N. Hold up. If K is even, first player wins. No, wait. If K is equal to N. Oh, 4. 1, 2, 3, 4, 5. This has to be all ones. So I need a Boolean. All ones equal true. If 1 is not 1, then we set it to false. All ones equal false. Then here, if it's all ones, check if K mod by 2 is not equal to 0, then it was first. Yeah. That would be N actually. All ones would be N. Okay. It should work now. Should work now. First, second, second, first, first, second, first. Shit. First, second, second, first, first, second, first. Okay, this should work. Let's just submit and see what this gives us. Wrong answer on 2. What is the problem? Huh? A01 is greater than or equal. So whenever a player gets the first pile with more than 1 stone wins. Let K be the maximum number such that all the values are equal to 1. Oh. Maximum index when all of them are equal to. Oh my gosh. Oh my gosh. This is so. I'm not reading correctly. Oh my gosh. Yeah, man. This is a tough problem. Yep. Okay. I'm gonna keep trying, and then once I get AC'd, yeah, then we just, yeah. I don't know how. I'm actually not sure how to get to green. Let me know your tips how to get to green. Let's see. I'm gonna try this again, and then yeah. Max K is equal to 0. If it's equal to 1, K plus plus. Otherwise, max K is equal to max K and K. And then we set K to equal to 0, but then we also want the max K index. That's the one we actually have to check. So that's going to equal to I plus 1. Right? So this is going to equal to I plus 1. So max k index is equal to I plus 1. Okay. Here, all ones, then we check n is not equal to 4. Okay. Here we check max k index. Okay. So dang. What am I doing wrong? Second first. 0 1 0 1 0 1 0. Max k index. K plus plus if equal to 1. None of this happens, so okay. This is annoying. Okay. If k is greater than max k. If k is greater than equal to max k, then what we do is we do this. Yeah. If it's greater than max k. Yeah. Okay, then after this we just need to what? My bad. Still wrong. How many wrong answers can we get? What do they mean? If it's k is greater than max k, still wrong. Let's see. First, second, first, second, first, first, first. So we get wrong on 1 2 2 1 1. 1 2 2 1 1. Okay. Just keep trying. Okay. That's wrong. That's wrong. What? Oh. Okay, I did it wrong. I did it wrong. I did I did it wrong. 1 5 1 2 2 1 1. Okay. 1 k is 1. Okay. Now it's not. So now okay, now max k is going to be 1. K is 0. Max k is going to be 2. Yes. 2. Max k is 1. 2. We didn't check the last one. Dang. Okay, we didn't check the last last k. So we have to do this again. This will be n plus. This will equal to n. Yeah. Yeah. Okay. This should work. I believe it'll work. You just have to believe, guys. The more you believe. Yes. Okay, it works. It works on this case. Let's believe that it will work on this one. Okay, I believe. All about believing. I believe. I believe. I do not believe. I do not believe. Why is it not working? First, second, first, second, first, second, first. How is it so hard? I think I'm implementing it right. Void make it simple. This is not even an algorithm problem though. This is just like, can I implement this right? So whichever person gets the first prize with more than one stone wins. Let k be the maximum number such that k1 equal to 1. If k is even, the first player will win. Otherwise, second player will win. The only exception is when all players have exactly one stone. In that case, k wins when k is odd. Okay. The maximum number such that a1 to k is equal to 1. Okay, we're going to keep trying, keep trying, keep trying. Keep trying. Keep trying, okay? If k is even, then the first player will win. The second player, otherwise the second player will win. Max k index. K is greater than max k. We set max k is equal to max k and k. K goes back to 0. Max k is going to index is going to equal to I plus 1. Okay, I'm not doing it this way. This is even more confusing. Okay, okay, so we'll just use 2 while loops. While. Okay, so this, and we'll have an integer j is equal to I, okay? So if we have 2 pointers, first one going to the end, second one going to the end, while the first j is less than n and j is equal to 1, j plus plus. This j is going to be the highest number that, yeah. This j is going to equal to the highest number that it's equal to 1 when you keep adding. So that's the highest index. What we're going to do now is we are going to get the max of this j. Okay, this j is going to be the max. So we need to get the max of this j and some number. Max k index, max k. Yeah, so k is going to equal the max of j and k. Why can't I do this? Okay, yeah, so that's going to get me the maximum k index. And then let's just say I equal to j. Okay, yeah. After this, we just check k plus 1 mod by 2. Okay, because we start at array 0 base, so then we'll just add 1. Okay, hopefully this works. What's the problem? Why are we stuck in an infinite loop? J is equal to 1. Ah, crap. Okay, J should equal to I plus 1. Okay, first, second, second, first, second, 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 first, what? First, second, second, first, second, first. First, second, second, first, second, first. We're getting this wrong. 1, 2, 2, 1, 1. We're gonna try this again. 1, 2, 1, 2, 1, 1. This should give me... Wait, what's max K? Okay, that doesn't work. We need to check if there's no ones. Hold up. Let's see this. Why is this not working? One, 5, 1, 2, 2, 1, 1. Okay, K would become 1. Yes. Actually, it should be J minus 1. If J minus 1 is not equal to I, then do this. That means we didn't move anything. Okay. Damn. Second, first. Okay, what are we doing wrong? Second, first. I don't know. Bro, do stream until you get an AC. Are you in? I'm in college. Yeah. Prefix array count of number ones. Keep going and stream until you get AC. Keep doing it. I will keep doing the stream until I get AC. One day I'll keep going. I'll keep going until I get AC. Dang. Why is this so difficult? 8. How many submissions have I done? 1, 2, 3, 4, 5, 6, 7, 8, 9. One, two, three, four, 5, 6, 7, 8, 9. Do they mean by the maximum index or do they mean by the maximum number? Like the number, like the maximum. Do they mean maximum index or do they mean by like the count of the number of ones? Like if you have like, okay, like this, okay. Let's say I have this 1, 2, 2, 1, 2, 2. Are they saying the maximum index? Because the maximum index would be 2. Okay, no, the count would be 2 also. Like this one. 1, 2, 2, 1, 1. So these last two 1s have a count of 2. The index is 5. Right? The maximum index of the last one is 5. So, oh boy, I'm gonna keep trying. I got it. We are going to use an array. We're going to push each. Okay, we're going to go back to our original code. This one, okay? Start at the beginning, go to the end, okay? What are we going to do? This is what we're going to do. If a of I is equal to 1, our k is going to increase. Otherwise, we're going to push, we create a vector of pairs. Let's make these longs. Okay. Vowels is going to push back k and I. Right? Vowels is going to push back k and I. So here what we're going to have is that we're going to have k is going to keep plussing, plus, right? Then after this, after a certain number of pluses, right? We're going to push back the k and the I. So then here is going to push back 1, 2, 3, 4, 5. Okay, so here we have 1, 2, 2, 1, 2, 2. This is going to push back 1, 2. It's going to push out 2 and then a 1. Get the index of 1. Okay? That's what it's going to do. Okay? Okay. 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 Then here, I'm going to set k back to 0. After this, we're going to sort this. We're going to sort values by rows and columns, okay? So now it's going to have the maximum k, okay? The maximum k is going to be at the end, okay? So now, after this point, I just have to get vowels at the end, which is vowels dot size minus 1, right? The last value has a maximum k. I just have to check if the index of it, so this is going to be index of k, it's going to equal to vowels at vowels dot size minus 1 dot second, okay? I need to check, does this, if this is even. If it's even, I will win. Otherwise, second will win. Okay. So if even, I have to add 1 because remember we indexed it by 0 in the beginning. Okay. So now we just check, is it even? Then player 1 will win. else player 2 wins. Okay? This should work. Okay? None of the whole keep searching until you find it. Okay? Ideally, this should work. This is lower time complexity, but it should work. This is n log n, but dang, it doesn't work. Okay, we have 2 second, second, first, second, second, first, first. Why? 254. 254 is going to do 0, 0. So this one's going to be empty. Okay. I gotta check if k is not equal to 0. So okay, so what we have to do is check if there's no ones. So no ones. So if there's no ones, that means that. So okay, so we have to create a count. Count ones equals to 0. If a of I is equal to 1, we count ones plus plus. Okay. This one we have to do if count ones is not equal to 0. So there's at least 1, 1. Then we could do these. Okay. Then you could do this. Here you gotta check if count 1 is greater than 1. Okay. Otherwise, if there's no ones, it's going to be 254. Max one would be 1, right? So then player 1 wins. It would be 0. The k be the maximum number such that player 1 wins. A of 1 to A of k is equal to 1. So it would just be 1. Or no, it would be player 1 would just win. If k is even, but if there's no maximum number, so k is equal to 1, or k is 0. 0, player 1 wins. Yeah, so player 1 would win. Okay. So else if count number is, so here see out player 1. See out first and then continue. Okay, hopefully this works. Come on. First, second, first, second, first, 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 second, first, second, first. First, second, first, first, second, second, first, first. What are we doing wrong? Oh. Okay, if it's not equal to 1, we push I minus 1. That's what we have to push. First, second, second, first, first, second, first. First, second, second, first, first, second, first. First, second, second, first, first, second, first. Okay, this should be right. Has to be right. Why? 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 I don't know. All right. I'll see you later, Terry. You were pretty good. You were pretty good. Okay, we have to keep trying. Keep trying. Okay. Let's look at their implementation. You are not allowed to view it. All right. I'm gonna. How do they know that you're not allowed to view the requested implementation page? Because it's a virtual contest. Oh, I don't know. This is so difficult. So difficult. More than enough to become green. I don't know. Green is hard. Why is it so hard? This is really hard. This is super duper hard. I don't know. Hmm. What are we doing wrong? I have no idea. I have no idea. I have no idea. No clue. Alright, see you later, Terry. It was great having you on the live stream. It was great. It is what it is, guys. What it is. Oh, we got one. We got one. Another concurrent viewer. Oh, no, never mind. We're down to 0. I don't know. I don't know why it's not working. I am pushing the maximum one. Push the maximum K. This is very, very, very difficult. Very difficult. Very difficult. Oh. Okay. Just keep trying, keep trying, keep trying, keep trying, keep trying, keep trying. How many problems have I solved? I want to see my code drills. Code drills. Bruh. Bruh. More than enough problems. National Women's Day. At 2OJ. Let's see how many problems I saw these. Let's see the ladders. So I finished one of the ladders here. All these. Let's see about this ladder. Maybe we can solve all these. See if that actually does change anything. I don't know. Then maybe I could try solving these. What about this? No, I could solve these. Solve these. Did I solve this already? Fixing typos? No, I did not. Did not. I don't know. I don't know what I'm doing wrong. Another 10 minutes and then just keep trying. Hard. Very hard. Very hard. What are we doing wrong? If vowels outside is empty. If it's not empty, then you could do it. Does that fix it? Nope, wrong answer on 2. I don't know. I have attempted 3 times, 4 times. Penalties. Who's Temptat? Who's this guy? He has a good drawing. 658. I don't know. How do you get to green? Never mind. How to get to green in Codeforces. This year, my way from gray to yellow. Okay, how did you do that? How did this guy do it? He did not do it from one. Okay, he didn't do it in 1 year. He did not do it in 1 year. I don't know. Stuck in a simple problem. Let's see the recent actions. Walmart hiring coding problem. This guy got the pupil. Wow. I want to get the pupil. He solved the fourth problem. That's impressive. Yeah, I couldn't even solve the fourth problem. I couldn't even solve the first two. Sage's birthday. I don't know. We got some concurrent viewers. Yay. No clue. No clue. I'm just waiting until this virtual contest round is over. They should have a way where you could just end it immediately. Because I don't know what I'm doing wrong. I actually don't know. Hey, this one? Oh. If N mod 2 first, otherwise second. Maybe this is the reason why. Nope, it's still wrong. I don't know. I don't know, man. I'm so lazy. I don't know. Let me talk to the chat. How are you guys doing in the chat? Are you guys doing good in the chat? In the chat. In the chat. We got 4 viewers? Do we? This is not this is not in the at all corresponding to the same number. Oh, now they are. Okay, we're at 3. We're at 4. This is good. We have 4 concurrent viewers. How about we talk, guys? We gotta talk. We gotta talk. Hey, how you doing, Saber? Is that how you pronounce your name? Saber, carry on, brother. How you doing? Carry on. Let's just keep talking. Let's have a conversation. You know, just keep. I'm trying to wait until the virtual contest is over so I can look at the editorial. Look at the implementation. 1 more minute left. I don't know. Sorry, I have no clue. I don't know. I don't know, man. I don't know. It's really difficult. Super duper difficult. Ridiculously difficult. I don't know. Yeah, no, I don't know how to do it. I am stuck and I have no clue at sequential nim. I don't know what my problem with my code is, so I'm just waiting until this is over so then I can look at some other people's implementation. Because I looked at the editorial and I can't figure out what I'm doing wrong. So yeah, I don't know. Should I start doing Code Chef? What do you guys think about that? I know Codeforces is a little harder than Code Chef. Code Chef has long contests, but like I don't want to spoil a long contest, but there are some problems that are decent on that. There's also, they have this algorithms and data structure boot thing on Code Chef. Hold up. There's like they have like a training program. This one, DSA learning series. You could do all these problems. I probably could skip all the basics. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Linear data structures, STL. 1, 2, 3, 4, 5, 6, 7. Binary search and conquer. Oh, it's finished. Yay. Okay. I'm gonna look at their implementation now. I don't know. I don't know what I did wrong. I actually don't know what I did wrong. How is this a DP problem? Huh? Just count. You're not getting the maximum? What is this XOR is doing? Is it just the first? That doesn't make any sense. I don't get it. Let's look at the cases that I failed. First word is different. Expected second, I found first. Yeah, I don't even know that input. Okay, where did this statement come from? It's the first occurrence? Why is it the first? Okay, I'm gonna delete most of these and then see if their thing actually makes sense. It actually doesn't, but I don't know. So, yeah. Let's take this out. So originally I had something like this, but if K is LC out second. Let's see if this works. I feel like this, I don't know. Ha? It's just the first occurrence of K? What was with the editorial saying maximum then? I don't get it. This doesn't make any sense. What? Oh my gosh. I don't get it. I actually don't get it. Why is it the first occurrence of the number of ones in the first time? Why isn't it the maximum number of ones? Right? Like, because if you have 1, 2, okay, like for 6, for this, right? If I pick 1, 0, and we'll pick another one, right? Pick another, first player picks 1, now it's 0. Second player picks 1, now it's 0. Third player does the n-1, right? So he picks 1, it gets 1. I mean, for first player picks 1 again, gets 1. Second player picks 1 again. Third player picks 1, 0, fourth 1. But if you, I demand a proof. They need to give a proofs. I don't. Why is it the maximum number of ones? It's not the maximum number. It's the first occurrence of one. That's what. This is wrong. They need to change this. It's the first occurrence where K is equal to 1. The first prefix. Yeah, I'm done. I am done. I'm done. Yep. I hope you guys enjoyed this video. Rate, comment, subscribe. It's been 2 hours.